おはようございます。私はリンです。はじめまして。よろしくお願いします。すみません。日本語わかりません。Good morning, this is Tony. And thanks for coming. I'm in charge of Vive technical support. So today I'm going to share the Web SDK introduction and also some content porting experience. And please allow me to introduce about myself. And almost 4 years ago, when I worked as a software PM with Valve to deliver the first generation content, I developed kits. I remember at that moment, there were just less than 15 VR titles for the demo. Then we realized that content is the king. Therefore, HTC has started up its own internal studio, which later became the Vive Studio. And we are very successfully to launch 2 VR titles, Arcade Saga and Super Puzzle Galaxy. And I'm very proud to be one of the creative team of Smash, which is selected into Ready Player One OSS version. And before starting our main topic, may I know how many people here you have not tried the Vive Focus? We prepare 10 units on our demo booth. So please take your time to enjoy it. And here is the main features, main spec of Vive Focus. It comes with 3K AMOLED display panel with 110-degree FOV. And the core processor is the Qualcomm Snapdragon with inside-out tracking technology by using the dual camera. And it has a built-in speaker, so you don't need to wear the extra earphone. And this is designed for comfort and easily to wear. And I believe most of you are familiar with our product. So I'm going to take this chance to introduce 2 successfully application our enterprise business. And we have seen lots of opportunities that the more enterprise are willing to adapt the VR technology on their sales promotion and the user experience. For instance, in car industry, interior design, and real estate. In car industry, we have cooperated with General Motors, BMW, Mercedes-Benz, etc. on Vive product. And this is the case we have cooperated with Toyota Taiwan to deliver the safety technology simulation VR experience. And Toyota has built up its own safety technology, such as adaptive cruise control, vehicle stability control, and the traction control system. However, all these technology terms are very difficult for consumer to understand and imagine. Therefore, we try to deliver and define the several different driving experience for the consumer to understand once the accident happened, how this technology can work to secure their life. Now let's see a live video demo. In the beginning, when the passenger enter the car and take the seat, and there is a tutorial instruction about the technology. And we designed 3 different driving situations, such as highway road, mountain road, and also traffic jam. So this is the case on the mountain road. So let's take a look what will happen. Please watch out. Wow, boom. Sorry, there is no sound effect. So this is the case that do not enable the technology. And Toyota has deployed this VR experience into more than 100 sales branch office in Taiwan. And one salesperson is very excited to share about us, the real story. That one day, a father with his son who came into this sales office, and the son just entered the university. The father originally decided to purchase an entry-level car. But after he has took the VR experience to understand how this safety technology works, then finally he had changed his mind to purchase this high-end car with the technology. So let's look again when the technology enabled. Yeah, once the same accident happened, the technology looks work. And secondly, we would like to share is the application on the market, education market. And since Vive Focus is easy to wear anywhere and you can go anywhere. So also for the students, it's very easy to learn how to use it. Vive Focus has become a better candidate for the education market. And Vive Do is one of our partners, who is founded in Beijing and led by the Dr. Sun Wei, who is the pioneer of the software school of Beihang University. And they have built up their integrated cloud system for the education VR experience. And the program are covered from the K-12 to the university level. And you can see that when the teacher create and edit the content through the online model library. So after they upload the content, there is another system called content management system to help to deploy the contents into the multi-user. And it also allows the multi-user interaction. Also, there is a charging system. So you can charge multiple devices together and upload the content easily in the VR classroom. And this is a real case that recorded in the VR classroom in China. And you can see that the teacher can easily to deploy the contents through the content management system to all the students in the classroom. And the teacher can do interaction with the students through the system. And this system also allows multi-user interaction, so they can learn from different places together. And in VR classroom, the student can do interaction between each other. And you can use either Vive or Vive Focus because it supports the different viewpoint switch. So you can see the global view or either the first-person view. And Vive Do has deployed its total solutions in dozens schools. For example, from the worldwide leading university like the UC Berkeley VR Research Center to the local universities, colleges, and even the elementary school in China. And if you are interested in these applications, please contact me later. So now we are looking forward to hearing the good news and great idea happening in Japan. So now let's move to talk about what is Vive. Or maybe we need to ask what is Vive. And here is the market research center we had research data we have done last year. And there are more than 400 helmets in the market. And this implies that the market is fragmentation and lack of standard. And in the past years, we have heard a lot of pain points from our developers. All the hardware is not compatible, and it lack of standard. And the nightmare of the developer is supporting repeatedly across different platforms. There is always a chicken and eggs problem. So we see that on one hand, that developer is looking for a platform with a huge user base to ensure that you can make the money back. And on the other hand, that for the consumer, the end user, they are asking what is the killer application on the platform. HTC as an ecosystem contributor, we try to build up a mobile VR open platform to support the cross-mobile solutions such as Qualcomm Snapdragon or even the Samsung Epsilon series. So for the content developed, you can do less optimization and also enjoy the high performance from the content side. So you can focus your effort to deliver the higher quality and quantity and without taking care of this device difference. And here is the scope of the Web SDK. So in the core of SDK is a runtime. And to support different system maker, no matter it's 3DOF controller, 6DOF controller, or even in the near future, it's a hand gesture and height tracking. We provide an open device interface to integrate these different devices to support the compatibility. And for the helmet, no matter it's all-in-one devices or it's mobile with tethered or mobile with slot-in solutions, we define an OEM SDK so that the system maker can change their system behavior according to their product defined, but without a change in the runtime. So therefore, for you as a content developer, you can just use our game engine plugin to develop your content. So you don't need to take care about the difference of this device or even the helmet. And now let's move closer to the software architecture perspective. And this architecture is to prove that it's doable and flexible to achieve our goal. And you can see that all of our applications are based on the Android framework. So it's all installable across different mobile solutions. And we define a standard interface, SDK interface with Qualcomm SVR. And to support cross devices, there is an open device plugin interface. And here are the main features of our Web SDK. So besides the SDK, you can see that for different develop, no matter you are a Unity plugin developer or Unreal or native API plugin users, you can use this plugin. And in the content, we support a 2D overlay, so you can do the system notification. And in the Vive Focus, we provide a virtual world, so you can have this virtual world to protect user from the accidents. And in later slides, I will introduce more about what is the interaction mode, model, and the gaze mode. And in our focus, there is a dual camera in front of the head mount. So you can have this grade level raw data to provide you to do the mixed augmentation reality. And lastly, there is an in-app recenter. So you can do recenter function inside of your application, except the system recenter. And in order to provide a better VR experience, in our runtime, there is a stereo rendering to generate the stereo view. And single buffer rendering is helped to display directly to reduce the image latency. And checking position is a feature that helps to shrink the dizzy issue. And asynchronous time warp is help you to reduce the post latency. And there is an overlay function for you to do the system notification. And in order to support various devices, we provide a config file for the lens correction. So you can collect different color or lens distortion according to your lens characteristics. So now let's go deeper about the first part of SDK, OEM SDK. And OEM SDK is an assistant of our runtime. And the target is to provide a feature to help the customer. You can different the system behavior according to your different product design. For example, if one vendor is developing a all-in-one devices like a focus, so you can define a recenter function to trigger to recenter the head mount and controller at the same time. And on another project, if you develop as a mobile-based solution, so you can only define the recenter to recenter your controller only. So all these differences are defined in our OEM SDK. So you don't need to change the core of the runtime. And here is another case that shows we can provide the different OEM vendor to customize the notification method or message. Now let's talk about the second part. And there is an open device interface to support different devices. For a device maker, you can implement a device service and plug in into our runtime. And currently, they already support 3-DOF and 6-DOF controller. And also we support various HMD types from the all-in-one devices to the mobile-based solutions. Today, we are very happy to share our milestones this year. So besides Vive Focus is running on the Vive Wave, we engage more partners such as Pico, IGE, Skyworks, and Creator Shaders. And we have developed with Link and Dodo Class Gadget on the mobile theater solutions. And also we verify with HTC U12 and Google Pixel series for the plug-in phone plug-in solutions. And we believe that the more hardware partner we engage, the user base will be grow up, and then for the developer, you can enjoy more benefit and profit on the platform. And this is a positive loop. Now let's introduce about the game engine plugin. And we define 3 different categories for the plugin. First is interaction, such as controller mode or gaze mode. And visualization, like the raycast or controller loader. And additions means the tools and utilities that we provide for your implementation. If you cannot find a proper API inside our plugin, you can directly call our low-level C++ code to get your implementation. So now let's explain how the interaction works to support both 3DOF and 6DOF controller. And we provide a unique prefab for you to support 3 and 6DOF controllers smartly. So in current design, if you connect with 3DOF controller, so we will use our built-in ARM model to simulate 6DOF position. So you can enjoy the 6DOF movementation. And once there is a new coming 6DOF controller model, so we will pass this information directly into your app. So on the AP side, you can receive and notify 3DOF or 6DOF controller information according to the real device connected. For example, this is the case running on the Focus. And later, once you connect it with two 6DOF controller, your AP can show two hands simultaneously. Instant play. This is the feature I personally like most. Because in early stage, once you need to revise the parameter, you need to build the APK to install into the device and then to run and check the result. And thanks for the technology, now you can use the USB cable to connect it between PC and the Focus. And you can run on the editor mode to see and check the result. An adaptive controller loader. And think about when you develop your application according to the black controller, like the left photo. And maybe half a year later, there will be a new coming model like a white controller model. And your application size, since we already integrate with this new white model inside our runtime, so we will help to automatically update the controller model into your application side. So for your content, you can use one version to support various devices, and you don't need to rebuild the application. And here is our new coming roadmap planning. So there will be a 6DOF controller, 4-bit rendering, and eye tracking, and also the hand gesture, spatial audio, and the room scale with 6DOF. In addition, we are going to have a boundary system, 3D reconstruction, and also more and more AR and MR applications. And all this demonstrates that HTC is committed to integrate up-to-date technology into our platform to enrich the ecosystem. And now, let's talk about the second part. And all this information are contributed by our internal studio, Two Bears. And Two Bears has launched its Arcade Saga in 2016 with 3 small games inside. And also 1 year later, there will be a Super Puzzle Galaxy, which is a puzzle game. So we divided 3 stages when we do the content porting. Firstly, it's an API transfer stage from different platforms. And secondly, you might need to consider if you need to refine the gameplay according to these different system tracking system. And lastly, which is the most difficult part, is to the performance optimization. So let's see an example. This is the case we porting from original PC Vive to the Focus. And after you download the plugin and import the plugin, and you can easily find the proper Wave VR prefab, and you find it and replace it. So that's done. And here's another case that shows from the Daydream migrate to the focus. And the process is very similar. And one producer from Sparkle Live, he shared in the last year on the conference that he only took 2 hours for this API transfer. So I believe it's not very difficult for each of you. So let's talk about the second stage. Since we all know there are 3 different tracking systems, I will just skip it. And firstly, we need to overcome one technology challenge: how to use your 3-DOF controller to simulate the 6-DOF controller. Right, it's quite a challenge. And we would like to share this workable method. Maybe you can have a more creative one. So we find that it's workable when you can use your raycast to select object. After you select it, you can move the object along with this vertical plane when you rotate the controller. And how to move on the Dept axis. So you can use the touchpad to move up to the far side and to move down to the near side. And then we would like to consider how to do the button mapping for different gameplay. In the PC version, you will have 2 6-DOF controllers with many buttons. So you can design many complex functionalities. However, when you move to the 3-DOF, you need to reconsider how to keep your main gameplay. And maybe you need to find an alternative way to keep your functionality. And in our game, finally we changed the game design. And in addition, we have to use the one alternative method to move and migrate our functionality inside the game. So let's see a demo. On the left is the original PC version. And in the main gameplay is to use the controller to change the sand with the controller, change the lobe and geometry to let the ball roll into the target hole to pass the level. And you can drag and drag the object anywhere to change the rotation to help you to pass the level. And in mobile version, we give up to change the sand. So we only keep you can put the object into the proper position, and you can rotate the angle to the correct angle. So after the ball enters the target hole, then it will pass the level. So you can also see that on the left side, there is a menu pop-up. It's originally designed on our left-hand functionality. So we use this alternative way to do this change. And another case is the Sure Shot. And both Super Puzzle Galaxy and Sure Shot, you can have the demo on your demo booth to check how we manage this gameplay. So originally it is designed on the PC Vive with the 2 hands. So one for bow and one for arrow to shot the enemies. And in the mobile version, we changed the weapon to the gun because it's more easily to management. And we also rearranged the dynamic attack area and lower the attack density due to the performance optimization. So we would like to bring a new thinking for you for discussion. How to co-design a gameplay between 3-DOF and 6-DOF. So for example, maybe you can consider to develop a simple functionality with a 1 3-DOF controller. And when your AP is running on the 2 6-DOF controller, you can provide a more comprehensive gameplay with more complete and challenge levels. So this means that you can design a one version to maintain one version to support more and more across the different devices to enlarge your user base. So the third part, performance optimization. And we all know that the capability between PC and mobile is quite difficult and difference. So for a developer, you can consider the target frame rate, and in Vive Focus is 75. And here is the real data we record in PC and mobile. So in PC version, you can enjoy the draw call up to 250 with the triangles more than 140K. However, in mobile version, you need to reduce the draw call lower to around 50, and with triangles around 20K. Here we summarize some optimization tips, and here we would like to share with you. And some of the content methods are collected from the internet. So firstly, we will decide what is a CPU bound or GPU bound. If it's GPU bound, then we will try to reduce the draw call, reduce the physics calculation, and also review our gameplay, game logic and loading time. And if it is GPU bound, so we will reduce the transparent part, mesh part, and vertex. And also we will change the shaders to see the result. And there are three common methods to reduce the draw code: dynamic batch, static batch, and GPU instancing. And in dynamic batch, we find that often we pack the texture into one atlas and share the one material. And please be note that skin mesh and clothes which cannot be batched. And there are some exception case like alternative scaling or something, too many vertex more than 900 or too many vertex more than 300. It will break in the courses. And we will also try to reduce the physics calculation. And there is a collection matrix in your Unity editor. So you can find it and to review what part you don't need to calculate. And for the raycasting, we do not recommend to use it. And if you want to use it, you can use the physics raycast non-alk. And we do not suggest to use the mesh collider. And you can lower the physics time step to reduce the physics calculation. And on the GPU side, that we suggest to use the mobile shader instead of Unity standard shader. And to consider the computation, for example, if it is the workspace position, you can start in from the float. And for everything else, like the vectors, HDR colors, you can start in from the half precision. And others, like very simple operations, you can use the physics one. And also remember to review the number of paths. And regarding to the lighting, some people may think about one single light is the rack, but actually it depends on your content defined. And you can use the light map if you want to use more than one lighting. And lastly, you can eliminate the transparent period. So lastly, we want to show a short case study. So originally, we found the PC version is lower to the around 40 FPS when we first porting to the mobile. And after we do such steps for the optimization, finally we can achieve up to the 75. So we use the object pool to improve the game jet condition and also to management the projectiles. And we use the mobile shader instead of standard shader, and to remove the unnecessary coroutines, reduce the transparent period and object. Also, we need to reduce the draw code, of course. So let's see a video result. So on the left side is the original PC version. So you can see lots of visual effects, a particle system. And also we use several customization shaders. And you can also see our original gameplay. It's one shot and one ball. And in the mobile version, like we remove all the particle system to simplify the visual effect, and also change the shader to the mobile shader. And also you can see that we change the weapon to the gun. To sum up, that Vive Wave, it is install VR runtime environment, so it can support multiple VR devices. And for the developer, it supports very fast porting for your implementation. And also there is an open hardware device to provide the connectivity. And it is a complete VR function support with the compatible with Qualcomm Snapdragon. So please join us with Vive Wave. Thank you very much. ありがとうございます。